What's missing in this application we built thus far? Of course, authentication and authorization. We got some dummy authentication implemented in the React part of the app already, but if we're honest, we're not really authenticating users there. We're just switching between different UI states, and that is all. We also got a dummy login route on the backend, but again, this route isn't doing anything useful thus far. Therefore, in this module, we will change this, and we will also not just work on authentication, which means logging users in, but we'll also work on authorization, which means that even if a user is logged in, we don't allow everything for that user. For example, you can't edit or delete places you didn't create. Therefore, in this module, we'll do one very simple thing. We'll add authentication logic on both ends, and that for me then also includes that we add authorization logic so that we control whether a specific user is allowed to do something or not. But let's start with authentication. Now, if we speak about authentication, let's have a look at our current implementation, because on the backend here, we got a login route, right? We can log in. We can send a request to the login route at least. But if we then have a look at our user's controller and there at the login function, we see that what we do in there is in the end very, very trivial. We check whether we find a user for the provided email address. And then if we don't find that user, or if the password of the user does not match the entered password, we return an error. Now, thus far, this logic isn't too wrong, though I'm not happy with storing the plain password like this, the plain text password like this in the database. We certainly want to change this. But still, even with that logic, what we return is not really helpful. I return a user object, and I return a message where I say logged in. This is not really anything that helps us on the front end. It's not a proof that this user is logged in, right? The server says so, okay, that is nice, but if we then in the future send requests from the front end to the backend, how exactly would we remind the server about the fact that the user in our front end is logged in? We get no data from the server which we could send back to the server to prove that the server in the past decided that we are logged in. So how would this normally work, and how should this work in a single page application REST API scenario? We have our React app and we got our backend server, and there we got certain routes or certain requests we accept. We use a HTTP client on the front end, like the Fetch API or like Axios, and we send requests to the backend. And some routes there should be protected, which means only authenticated users should have access, and other routes are open to everyone. Now, traditionally, and with that I mean a web application where we render HTML on the server with the help of templating engines, traditionally, we would establish a session. We would create a session on the server. A session is a server-side idea, which we then store in the database there. And we would send the session ID to the frontend and there store it in a cookie. Now, this approach is generally nice, but if we're having a single-page application and then a server-side API, these two ends are not as closely connected as they are in an application where the server-side renders the HTML code. To be precise, the API is stateless, which means it's totally decoupled from the front end. It doesn't want to remember sessions and to which front end a session belonged and so on. Instead, we'll use a different approach when we're working with a single page application on the front end and an API like a REST API on the back end. Instead of creating and storing such a session on the server, which we don't want because the server is stateless, we generate a token. This in the end is a string generated with a certain algorithm where certain pieces of data are encoded in. This token is returned to the frontend, and there it can be stored in a cookie or in local storage. Now, this token then can be attached by the frontend to requests that request protected resources. And now the interesting thing is, the server generates this token, as I said, with a certain algorithm, and also by using a private key, which then is just a string that's fed into the algorithm, and the same key for the same data which is encoded will always yield the same token. A different key with the same data will yield a different token. So the server is the only one who knows this private key, which in the end led to this exact token, and therefore the server is able to validate the token which is attached to an incoming request. So on the front end, if you try to fake a token, if you would try to change anything there, you don't know the private key, so you will get a different token, and such a token would be identified as invalid by the server. And with this approach, we don't need to store any data on the server except for this private key, because we then on the server know which tokens make sense for this provided private key. And on the front end, we can use this token to attach it to requests where we need to identify ourselves as authenticated. That's the idea here. That is how authentication typically works in modern web applications, where we have a single page application and an API backend to talk to each other. And this is the approach we will therefore also implement in this course. So back in our code, again, I got two windows, one for the backend and one for the front end. You can see it on the top left corner. And I want to start on the backend. There, I want to start by ensuring that we are generating such a token. But actually, I want to start one step earlier when a new user signs up, when we create a new user. Right now, we always store the password as plain text in the database. And thus far, this was okay because we had no real authentication anyways. But now I want to change that because we never ever should store passwords as plain text in the database. Why? Well, if our database gets compromised by an intruder or by an employee who isn't happy, so if someone gets access to our database and is able to extract data from there, if the password is stored in plain text, this attacker has everything, all the information it needs. If the password instead is encrypted, so if it's a string which can't be decomposed to the original password, then the attacker might still have the email and the name, which is bad enough, but at least the attacker doesn't have the valid password. So the data which can be extracted is less useful. Therefore, we don't want to store the password like this, but instead encrypt it, hash it before we store it. And for that, we can install a third-party library with npm install --save. And the name of that library is bcrypt.js. This is a Node.js library that helps us create secure passwords, or not create passwords, but hash passwords, which means encrypt them, convert them to an unreadable string or to a string which can't be reverse engineered, to be precise. So with that installed, we can rerun npm start. And now in the user's controller, I want to import this library. So there I will import bcrypt by requiring bcrypt.js like this. This library now helps us with hashing passwords. So in the create user function, in the signup function here, therefore, we first of all still check if we have a user, that's fine. But if we come to the conclusion that we can create a new user, I don't want to create this password, but instead, as I said, such a hashed password. Now to generate this, we can call bcrypt, and then there we have a hash method. To the hash method, we pass in the password we want to hash, and that is the password we're extracting from the incoming request, so the plain text password. A little side note, by the way, of course, data between the frontend and the server should be exchanged via HTTPS, but that is something which you don't control here in this controller or on the front end, but in the end, with the service you use for hosting your application. So I assume that this is the case in production. By the time we receive the password on the server side, we of course automatically unpack it back to plain text, but ideally it was transmitted via HTTPS. So once we got the password here, we pass it to hash, and then hash also takes a second argument, which is the so-called salt, or the number of salting rounds. Now here 12 is a good value, and this simply influences the strength of the hash and how easy or hard it is to reverse engineer it. And with 12 salting rounds, we should have a hash which can't be reverse engineered and which still doesn't take hours to generate. Now hash then returns a promise. So since we're already in an async function here, thanks to async in front of our function parameters, we can of course await this generation, and the result will be the hashed password here. Now of course, as always, this could fail. It shouldn't, but it could, so let's wrap it with try catch and catch any potential errors here. And if we got an error here, well then I will create a new HTTP error and say could not create user, please try again, and send back a 500 status code because this then is some kind of technical server-side error. And then we can return this error with next here as we did it before. So normally we should make it past this try catch block though, and then we have a hashed password. Now when we create a new user, we set the password key, the password property of that user object, to that hashed password now. And we don't store the plain text password therefore, but the hashed password. Now with that we store this hashed password, but of course the next question is, how do we identify the user by the password then? Because comparing passwords like this won't work anymore. After all, in the database we won't have the plain text password, so we can't compare it to the password entered by the user. And if we did this, if we're sure that we have the right password, how do we generate this token? These are the next questions we have to take care of. So we're hashing the password. Now before we dive into the token creation, let's go to the login function and check how we now actually, with the password being a hash instead of plain text, can compare the password the user sends us, which of course in the end on the server is plain text, to the password in the database, which is not plain text. Now for this we can again use the bcrypt library, because there the idea is that the bcrypt library knows how it created the hashed password. If we provided a new password, a plain text password, it can find out if that password could have been used to create the hash that's stored in the database. So we will in the end not recreate the hash, but we will check if the hash we have for the password in plain text that is provided makes sense. So therefore in the login function, we will still check if we maybe don't have this user. So I will remove that second check here and just check for the user existence. And if we don't, we already return an error, because that means we couldn't find a user for the provided email address. If we do find a user though, then we can check the password. For this, I will add a new variable, isValidPassword, and by default set this to false maybe. And then here, I set isValidPassword equal to await bcrypt compare. Compare also returns a promise, and compare now takes the plain text password, which here is in the password constant. We're extracting this from the incoming request. So we compare the plain text password to the hashed password in the database, so to existing user.password. So this is now not the plain text password, but the hash. We compare that, and this returns a promise, which then in the end yields a boolean, which I stored in isValidPassword. Now as always, and that's why I split this into a variable declaration and then usage. As always, we want to wrap this with try catch to catch any potential errors. Here we can just say new HTTP error, could not log you in. Please check your credentials and try again. However, this is a server-side error. This error will not be thrown if we have invalid credentials. This is just an error if something went wrong during the comparison. Instead, we will always get back a boolean even if the comparison fails. Even if we can't confirm the password, we don't get an error. Instead, we just get false as a return value here. So therefore, thereafter, as a next check, I will check if isValidPassword is false with an exclamation mark at the beginning. Because if it is, then we can again return our invalid credentials error. Because here we know that the password is not correct. If we make it past this if check as well, we know the email address exists and the password is correct. So then we can generate the token. Now for that token, I mentioned that it would be a string in the end which we generate, which is generated with the help of a certain private key and a certain algorithm. And then we can encode data into that string. So we can, for example, encode the user ID that belongs to the token into that token. You won't be able to read it directly in the token, but you can then decode the token to find out which data is in there, for example. So to create such a token, we'll install another third-party package. And this package is called JSON Web Token. One word, and simply install it with npm install -- save. This is a package which allows us to generate such tokens with that private key. And therefore, here in user's controller, where I want to generate such a token, I will import it and store it in a JWT constant and import it with required JSON Web Token. Of course, you can name these constants here whatever you want. Let's restart the server with npm start thereafter, and now we can adjust our code. And I want to generate such a token both for sign up, because if a user is signed up, I know that this is a valid user because, well, we just created the user. So we can also create a token there. And of course, I also want to generate a token for login. So let's start with sign up. Here, we're storing a user in the database, so thereafter we know this is a valid user. And now we can generate such a token. And it's thereafter actually the token and maybe some user data which I want to return instead of the entire user object, because not all user data is directly required in the front end here. But that of course depends on the application you're building and your exact requirements. So here I will add a token variable, and then to create it, we can call JWT, so this package I just added, sign. The sign method here returns a string in the end, and this string will be the token. So we can actually say token equals JWT sign, and then it takes some arguments, some inputs. The first argument here is the payload of the token, so the data you want to encode into the token. And this can be a string, an object, or a buffer. Now here I will encode an object, and the entire serialization and encoding logic will be handled by this package. So here we have a vanilla JavaScript object, and there I want to encode the user ID into the token so that we know which user this token belongs to. And for that I will use my created user .id. ID is a getter provided by Mongoose on every created user document object we're working with, and this is the ID MongoDB will have generated for this user. And maybe we also want to encode the email address, but it's up to you which data you want to store here. I just chose some examples. So here I'm encoding the user ID, which is very important in my case, and the email into the token. The next argument here is this private key. So this simply is a string which only the server knows, so which you never ever share with any client. It's only in your server-side code. And here I will name this super secret don't share. And of course you can enter any string you want here. The last argument is optional, and here you can configure the token with a JavaScript object where you can set up certain options. For example, you can set a token expiration with expires in, and this accepts terms like 1 hour like this. You can check out the official docs of JSON Web Token to find all information about all config options here and about all the time strings you can pass to expires in. Now, letting the token expire is actually a really recommended practice because the token we send back can't be faked or edited by the client, because whenever you would do so, since you don't know the private key, you would generate an invalid token. So even if you decode it on the front end and you tweak the user ID and try to recreate the token, you won't be able to replicate this token because you don't know the private key on the client. So that is how we secure the token. But if you steal this exact token we're generating here, if someone gets access to your token, then this token is enough to fake that this person is you, because this token is accepted by the server as your identity, so to say. It's accepted as your I am logged in proof. Now, stealing that token on the client is a different thing. It's not that easy, and I will talk about this when we actually store it on the client. So it's not that easy to steal that token. Still, as an extra security mechanism, it is recommended that you let this token expire, for example, in an hour, so that even if it would be stolen, there only is a very short time duration during which attackers could do something with it. Now, this token creation also could fail, so I will wrap it with try catch here. It doesn't return a promise, but it still could fail. So here, try catch. And if it does fail, I will just return my signing up failed error here. If it does not fail, however, we do have a token, and therefore now I can return this as part of the data I want to send back. Now, the data I want to send back totally is up to you. Here, for this user sign up process, I will send back the ID of the user that was created, which I get from created user ID, the email maybe, which is created user.email, and very important, this token. These are the 3 pieces of data I want to return here, but again, it's typically up to you what you want to return to your frontend in the application you're building. Now that was the sign up process. Let's repeat this for the login, and of course feel free to pause the video at this point and try this on your own. After a short pause, which I give you to pause the video, we'll do it together. So, were you successful? Of course, it shouldn't be too hard. We can just copy this token creation code here and go to the login process here. And once we validated that we do have a user for this email address, and once we also validated that the password is correct, so right before we send the response, we want to generate this token. Now, important, use the same private key as above. If you use a different one, you will generate different tokens. And therefore, when the client later sends a token with a request, you wouldn't be able to validate them correctly on the server. And here this should be logging in, I guess. So make sure that you use the same key here in login as you did in sign up. I will also use the same expiration date, of course. In general, I want to have the same configuration for my token. Just the data I encode is generally the same, but here in login, I don't have the created user. Instead, we have the existing user here. So I get my ID, which I want to encode from existing user ID, and the email from existing user email. Other than that, it's the same logic, just the error message changes to logging in failed. And then here, as a response, I don't return a message, I don't return the user object. Instead, I return the user ID, which I get from existing user ID, maybe also the email, which we get from existing user email, and very important, of course, the token, which we just generated. And with that data, the client, so in our case, the React application, will be able to use and store this token and attach it to future requests to routes on the backend that require authentication. And that is actually the next step. We are generating this token, but thus far it's totally useless. Thus far on the client we could store it or we could not store it, because besides this token generation, we haven't added any logic to the backend that would protect certain routes from unauthenticated access. Right now you still can send any request to any route here. We're not blocking this. So as a next step, we want to make sure that certain routes, like creating a new place or patching or deleting it, are only accessible if the request has a token attached to it, and this token also is validated by the server, and we can confirm that it was created with this private key. So as a next step, we'll implement this route protection on the backend. So we got certain routes on our backend, to be precise, the route for creating a new place, for updating a place, and for deleting a place, which should be protected, which means you shouldn't be able to send a request to them if you're not authenticated, if you don't have a valid token. Now, how can we ensure that no request without a token, or without a valid token, I should say, can reach these 3 routes? Well, we can add a middleware in front of them. We can add a middleware in front of them, which ensures that requests have to have a token. If we use router use here, we can add a middleware to any request that reaches this middleware. Now keep in mind that requests in the end travel through your middleware from top to bottom in your files. And if we add a middleware here, we therefore ensure that these first 2 requests here are open to everyone, And that actually should be fine here. I'm fine with returning place data to everyone. But then, once a request didn't make it into this or this route, it encounters this middleware. And here we can then do something to, for example, send back an error response if the request has no valid token. So a request without a valid token will never reach the bottom routes here because it will always be handled by this middleware. That is the plan. So we need to write a middleware here which checks an incoming request for a valid token. And if the token is invalid, it will send back a response and it will block the request from continuing its journey to the other routes. This is how we could protect these bottom 3 routes here. So the only missing piece at this point is a middleware that helps us do that. And for that, I will create a new file in the middleware folder, which I'll just name auth or check-auth.js. And in here, we'll write all the logic to validate an incoming request for its token. So in the end here, I want to export a function, right? Because a middleware is a function, as you learned, a function which gets this request object, this response object, and this next function here. And then here, we want to check whether we have a token, and not just whether we have a token, but if it's a valid token. So first of all, we can extract our token from the incoming request. And now the question is, where do we expect this token on the incoming request? You could argue that it should be part of the request body, but you might not always be protecting routes that have a request body. For example, the delete request doesn't have a request body, so the token couldn't be part of the request body here. Any GET request wouldn't have a request body. We're not protecting a GET request in this application, but in other applications you might be protecting such routes as well. So the request body is not a great choice. You could go for query params instead. Query params are these things in the URL which come after a question mark, something like token equals, and then your token. That could be part of the URL, and that would be a valid way of sending a token. But I personally am a friend of using headers. This does not affect our URL and therefore keeps it cleaner, and a token really can be considered metadata that is attached to a request. So I really like the idea of encoding the token in the headers of the incoming request. So we can access the request object, and there we will find a headers property. This is automatically provided by Express.js. This is in the end a JavaScript object where we got key value pairs, where the keys are the headers and the values, well, are the values for these headers. And there we will find an authorization header. Now remember that earlier in the course in app.js, when we worked on the course headers, I allowed the attachment of an authorization header. Now here with a capital A, but headers are actually case insensitive. So here we're allowing the frontend, the client, to add an authorization header. And now I'm using this authorization header here, again, they're not case sensitive, to extract data. So I access this authorization header, and in there I expect to get my token. However, this header will not be authorization and then the token. Instead, the convention is to have as a value something like bearer token to indicate that this request basically bears such a token here. So the token here is part of the string which is stored in the authorization header. So we want to split the value in the authorization header on the white space, on the blank. So basically here on this white space. And as a result, we will get an array with 2 values. The first value, the first element will be this bearer string. The second element will be our token. So on the result of this split operation, I can access the second element with index 1 because indexes in JavaScript start at 0 in arrays. So this should be our token. Now, of course, that token might not be found or it might be invalid. So if we don't have this token, if it's undefined, if this fails, then I, of course, don't want to continue. Instead, we know that we certainly have no valid request at this point. So here we can create a new error, a new HTTP error, and for that I will import my HTTP error by requiring it from models HTTP error. And there, as a message, we could say authentication failed. You can, of course, also provide a more detailed message and send back a status code of 401 for not authenticated, basically. And then here, I call next and attach my error. And I also return this to ensure that no code thereafter executes. Now, the problem we also have here at this point, by the way, is that when we split this, if the authorization header is not set at all, this would actually crash and generate an error instead of just returning undefined for the token. So we should actually also wrap this with try catch here to catch any error we might be having here. So this should go into try, and then actually we can send this error in catch. And here, where I check for the token existence, I just want to throw an error. I just want to throw a new error where I say authentication failed, but that doesn't matter too much because in the catch block I generate a new error anyways. So with that, we're handling two scenarios. Scenario one is that the authorization header isn't set at all and therefore split fails. And scenario two is that it succeeds, but whatever we had in there doesn't give us such a token. Now, if we survive both cases, so we do have a token, the token still might be invalid. So as a next step, we need to verify the token. And for this, we can reuse this JSON Web Token package. So I'll import it here, JSON Web Token, and store it in the JWT constant. Because this was the package we used to generate the token, it's also the package we can use to verify a token. So for this, we can call JWT verify. Now to verify, we pass our token, and then as a second argument, the private key we used to generate the token. So we have to use the exact same key we used in the user's controller to generate our tokens. So make sure to copy it from there and not introduce any typos. Because of course you can only verify the token's validity if you use the exact same private key. Now this verify process will not return a boolean, instead it returns a string or an object. It returns the payload that was encoded into the token. So here we got our decoded token. And from that payload, we can therefore also get the user ID to which this token belongs. Because remember that when we created the token, we stored the user ID and the email in the token. So when we call verify, in decoded token, we got an object which has this user ID and which has this email. And now here, we know at this point that if this didn't fail, if this verification didn't fail, didn't throw an error, that the user is authenticated. So at this point, I also want to call next here and not add an error, but instead allow the request to continue its journey so that it is able to reach any other routes thereafter that require authentication. But I also want to add something to the request object. I will add a user data property. You can always dynamically add data to the request object like this. And the user data I want to add to the request includes my user ID, let's say, which I get from the decoded token and their user ID. Because again, when we create the token, we added a user ID to its payload. So now every request thereafter will be able to use this user data object, which is part of the request object, and get that user ID we extracted in this middleware. So we're doing two things here. We're validating the token, and once it is valid, we let the request continue and we add data to the request. Now, if verification fails, this will throw an error and therefore will make it into the catch block. This, therefore, is the finished authentication middleware. And now my app crashed after saving because in places routes I have this empty middleware. But this here will now not stay empty. Instead, here we can now use this finished middleware. So back here in places routes, let's import check off by requiring middleware check off. So the middleware function we're exporting there. And here in use, I just point at check off. I don't execute it because this already is the middleware function. Instead, I just pass a pointer at this function to use so that this function gets registered by Express as a middleware. And now with that, any route after this check here, so all these routes at the bottom are protected and can only be reached with a valid token. I can already prove this. If we go back to the front end and we try to authenticate here, for one, you see that this fails we could not log in because we created this user here earlier in the course, and therefore it has its plain text password stored in the database, which can't be compared with the new bcrypt hash algorithm. But for example, if I create a new user here, pick an image like this here, and then unused email address, now we sign up, but we're not redirected. The reason for that is that we changed the data we're returning on sign up. We're no longer returning a user object, which is what we expect on the front end though. And therefore login here in the end failed when we try to extract the ID from the user object on the response, which is no longer there. But since we don't do anything in the error handler, we didn't see an error for that. Now that's not a problem because this is an error we will have to fix as a developer anyways. Our returned data changes, and in general, how we work with this authenticated user changed. Nonetheless, important is that you won't be able to send requests to the backend, to the protected routes now without a token. And whilst I can't show this here in the front end, we can of course use Postman for this. Here on Postman, I created a request to create a new place with some dummy data. And if I click send here, you see I get back a 401 error here, authentication failed. So this proves that this request doesn't even reach our protected route. It's blocked earlier by our brand new middleware. And that is exactly what should be happening. So now with that, let's work on the front and make sure we use that new returned data, that token and that user ID which is returned. And we then kind of store it on the front end and also attach it to requests we send to the backend to ensure that we have access to the protected routes again. So let's make sure our app works again. And for that here, I'm back on the front end now. I first of all need to use that new data the backend returns for logging in or for signing up. In both cases, we return an object which has a user ID field, which has an email field, and which has this very important token field. So here to auth log in, thus far, I passed my user ID. Now, of course, I can still pass this. It just now lives in the user ID field instead of the nested user object. So we can simply change this to user ID and it should generally work again. But with that, we're not taking advantage of the token. Still, with that, if we try to authenticate with that new user, which was created after we changed our password hashing logic on the backend, if we click login here, we are redirected. So this now at least works again. We're not crashing our app anymore. Nonetheless, this is not all. I also, of course, now want to use the token we are getting back from the backend. So to log in, I will also forward response data.token, both here for our login mode logic as well as for our sign up logic. And in app.js, where I have this login function, I therefore now no longer just expect the user ID, but I also expect the token as a second argument. Now, of course, I want to manage my token here in state, and actually instead of is logged in, I will store token as a state here and set token, and therefore call set token here and set this to the token I'm getting as an argument. And on logout, we can set this back to null. And therefore here, where I check for is logged in, I can simply check if token, because if token is null, I'm not logged in. If it's something truthy, like a string, which it is, then we'll make it in here. Else, we'll make it into here. And then here at the bottom, where I set is logged in on my context object, I can set this to token with a double bang in front of it as well. And therefore, this will be converted to true if it is truthy. So if it is a string, if it is a token, and to false if it's falsy. So if it's null or something like this. In addition, in my context, I also want to store the token itself though. So this is just a convenience property here, which gives us a quick answer to the question whether we are logged in or not. I want to store the token itself as well though, because later when we send requests from certain places in the app, we will need that token. Now to be consistent, I will therefore also go to the context, to the auth context file, and here in our setup also add the token as a field to the default value. We never really use that default value, but it's better for auto completion if we reflect the actual values we'll have in the context in the end here as well. So now we're storing the token in the context, and we're storing the answer to the question whether we're logged in the context, just as before, just with a different logic. Now we can utilize this token to attach it to outgoing requests. So for example, when we create a new place, so in the new place.js file, we're sending a request, and this is a request which needs a token, because on the backend, in the places routes, we are protecting all routes below this middleware here, and that, for example, includes the create a place route here. So we need to add our token. And if you check our middleware logic on the backend, you see the token has to be part of this authorization header. So here, when we create this request, when we send it, in the end, the send request function here we have from our custom HTTP hook takes a headers argument. So here I want to add my headers, which is an object of key value pairs, and I want to add the authorization header here and set this to, important, what I expect on the backend, bearer, and then my token. And this bearer thing is really just a convention to identify this kind of authentication, basically. So I'll set this to bearer, white space, and then my token. And we get that token from the auth context, to which we already have access here. So auth.token. This header now needs to be attached to the request, and we should be able to create new places thereafter. So if I save this, and I log in again, and make sure you use the right email address, which you used to create a new user after you changed your sign-up logic and hashed the password. If we now go to new place, Marienplatz, still a nice place in Munich, Marienplatz 1 in München, and we pick our image. If I click add place, we're getting an error. And we're getting an unauthorized 401 error. Now we're getting this error for an options request though. And such an options request, if we inspect the network tab, is indeed sent. You see that when I try to create a new place here, it sends a request, but please note that the type here is options and not post. But we clearly are sending a post request here. Well, that's just a browser behavior. For certain HTTP verbs, basically anything but GET requests, the browser automatically sends an options request before it sends the actual request you want to send, to find out whether the server will permit this to be sent request, so to say, if the server supports the to be sent request. This is just a convention, this is just something the browser does, and we just have to be aware of it. And we have to handle it. This options request has no token attached, and it doesn't need to. So in checkoff in our backend middleware, before we try creating the token or getting the token, I want to check if the request method is equal to options. And if it is equal, I will return next and allow this request to continue. This will not allow the post request to continue, just this options request. So this is a required adjustment to ensure that our options request is not blocked. The actual post request, which then triggers our place creation logic, will still be validated. So with this change on the backend, now if we try this again, this looks way better, and we created a new place here. Now what you'll notice, of course, is that if I try to delete this place, we fail because authentication failed. And that makes sense because we're not yet attaching the token to this request. The same is the case if you click this update button here. So we need to attach the token to these two requests as well. This definitely is a great practice for you, so feel free to try this out on your own before we'll do it together in the next lecture. So let's make sure we also use our token on update and delete requests, because these are the two remaining routes which are protected. So for that, let's maybe start with update place. There we have our HTTP request here, and there we already are attaching a header, but of course we can attach more than one header. We can also add authorization here, and now we need access to our auth object, our auth context. Conveniently, we already got access here, so we can just tap into this existing auth object here and get our token from there. However, remember, what we added to authorization is not just a token, but actually bearer plus token, just a convention we're following here. With that, we're adding the token here, and this should be all for now. Now let's also do this on place item.js, where we have our delete functionality. Here we send the delete request, and at the moment all I do here is set up the URL and then add my method here. Now we certainly need no body, so we can pass null here, but we want to add our headers object. And there we want to set authorization to bearer plus auth token. And we already got access to the auth context object already in this file here. So with that, the token is added to all these requests, and hence we can give that a try and quickly authenticate here with the right user. We will later, of course, also add a functionality to stay logged in. And now if I click edit here and I click update, this works. And if I click delete, this also works. So we are able to update and delete places. We are adding the token there, but we still got missing functionality. For example, we still can delete and update places that don't belong to us. We're having some security mechanisms here on the front end. For example, we only show the buttons if we're the right user, but we could use Postman to delete places which don't belong to us because we have no server-side protection against that. And addition to that issue, on the front end, we have the problem that whenever we reload, we are logged out again, which of course is also not great. So there still is room for improvement. So let's improve our application a little bit, and for that I will start in MongoDB actually, and I just want to make sure that I delete my user, which I created before we hashed the password and which therefore still has a plain text password stored. This user here. I will just delete it to have a cleaner database. The other user, as you can see, has a hashed password stored. Here it is. So that's just a tiny fix, however. With that fix, I will log in with that remaining user I have and create a new place again. So the good old place we already know, Marienplatz in München, which is still a very nice place, at least for tourists. The address is Marienplatz 1 for me here, and I will reuse that image I used before. Click add place and it will of course work. Now we can also edit and delete this as you learned, as you saw before. And that's all nice, but anyone can do that. Here in our app, only we see these buttons. If we would log in with a different user, they would be gone because on the front end we have this check when we render these buttons, where we check whether the logged in user ID equals the creator ID of our places. We have no such check on the backend though. There, in places controller, when we delete a place, I find a place, I populate its creator, and then I just go ahead and I try to delete it. Now, this might fail because I'm trying to also remove that place from the array of places mapped to its creator, but this is not guaranteed. Most likely this will succeed. And for updating, here, update place, we're also not checking whether that place really belongs to the user who sent the request. We're just finding the place, we're editing it, and we're saving it back. So we have no checks on the backend to ensure that only the user who created a place is able to change it. I want to add such functionality though. And just to again highlight the problem, if I go to Atlas, to my places, and pick the ID of a place which is stored here, the place I just created, and I then go to Postman and send a patch request to this place. And there I need to add the authorization header here as well and set this to bearer and then a token. And now I need a token of a user who did not create that place. So for that, back on the front end, I will log out and create a brand new user, Manuel, who surprisingly looks like me because I only have that image here. And now there I'll of course use a different email address, create that user, and now I have Manuel as well. And Manuel did not create my place, so here in the app he doesn't see the buttons. But of course I can use Manuel now to still edit the place here. For that I will just log Manuel in here with Postman. So send my test@test.com and the right password data to the login route. I get back a valid token because this login, of course, succeeded. And I can use this token now here on the patch request as my token I add here to bearer. And now send a request to that place I created on the other user, so not on manual but on Max, to change it. Marienplatz, and add multiple exclamation marks. A great place. If I do that and I hit send, this succeeds. It edited this. And therefore on the app, when I reload here, we see these changes. Now that's exactly what I don't want. So let's ensure this won't work anymore. And for that, on the backend, let's add some extra security. And let's start with updating. Here in update place, the goal is to ensure that we only continue if the user who's sending the request is the user who created the place. Now the good thing is in the check-off middleware, we are extracting user data and I'm storing the user ID here, which is part of the token. So that gives us the user ID of the user who sent the request. And this also can't be faked or anything by the client because it's part of the token. And if you would change data in the token, you would generate a new token which wouldn't be verifiable anymore with this private key. So it's 100% unfaked data. So we have that user ID stored in the user data object on our request. And therefore here in update place, once we made it through the general validation, we're looking for a place here, and a place has a creator field, of course, this one, and this will be the ID of a user. So then here we can just check if place.creator is not equal to request user data.user ID. If that's the case, we know they're not equal, and therefore we know, well, this user did not create this place. And in that case, I want to return an error, of course. You are not allowed to edit this place. And this now actually is a 401 error because 401, which I used before, actually is an authorization error. I'll switch the other error codes in a second. And we send back this error if we determine that this user is not allowed to edit this place. And only if we make it past this check, so if the place was created by the right user, we allow this change. So now if I save this backend and I try this same update request again with the same token, which still is valid here because it has been less than an hour that I got it, I get this error here, not authorized. Now, on the front end, we can check the opposite. If I log in with the user who did create that place, who should be able to edit it, I see that button. But now if I remove all the exclamation marks, I also get this error. So why is this not working? This, of course, should be working, right? This is the correct user. This is the right user. Now, this is not working because of the exact check we're running here. What's inside of creator? It's not a string that will equal this user ID here. Instead, it's an object of type Mongoose object ID, this special ID type Mongoose knows. So we have to convert it to a string by simply calling toString here, which is a method that will be available that will convert this to a string. And then this comparison here should succeed. So if we change this on the backend and we reload, now if I remove the exclamation marks here and I click update place, this succeeds. So now the user who created this is able to edit it, whilst the user who did not create it here, if we test it again in Postman, still gets an error. So this is now added authorization. Now feel free to also add this on your own to delete. I'll do it in the next lecture, and thereafter I'll also make sure that we use different HTTP status codes, which is just a minor thing, but still, to reflect the right kind of authentication error we're having, whether we're really not authenticated or maybe we are authenticated but we're not authorized. So let's ensure that only authorized users can delete a place. Now, here we again extract our place and we populate the creator. That's important. Creator is now not just an ID here, as it is here in update place, where I just find the place and I don't populate creator. Instead, with populate creator, the creator field holds the full user object. That's important to keep in mind here. Now, still here we find a place, and if we don't find a place, we throw an error. But if we did find a place, I want to check if the place was really created by the user who sent the request. So here we can check if place.creator.id, and again, keep in mind that creator here is the full user object, which is why I access ID like this here, if that is not equal to request user data.userid. So a similar check as we have it up here in the update place route. Now important here, you don't need to call toString because this ID getter here already gives us the ID as a string, and therefore the check should be good like this. If we have a problem here, we can basically use the same error we used up there. So copy that down and return this error where we say you are not allowed to delete this place in this case here. So now if we save this, let's give it a quick try. Let's try to delete a place by here switching patch to delete in Postman. The URL is right and the headers are right. And now if I send this, I get you are not allowed to delete this place. On the other hand, on the front end, with the right user here, if I click delete and I confirm this, it should succeed, and it does. So this here is now working, and we got authorization added. Now as a last step, as a little bonus actually, I'll fix some status codes. Thus far I always used 401, and to be honest, in the end it's up to you what you use here. It's not that strict. But if you want to be very correct here, then 401 means unauthorized, which means you might be authenticated, but you're still not allowed to do this operation, to perform this operation. We have 403, which means this is forbidden in general, which you could translate with you're not authenticated. So here I want to search for my 401 cases and check if they are all correct. So this is my user ID comparison and this is, so here they are correct. In the user's controller, on the other hand, if I have 401, then here we have invalid credentials, so 403 makes more sense there. And then check off, it's the same. If we fail because we have no valid token, I would say it's rather a 403 error. But ultimately it's up to you, and it's not the end of the world if you use 401 instead of 403 or vice versa. The important thing is that we have this logic added here. So we got authorization added, we got authentication added. Our app is really working quite well. If there wouldn't be one issue, whenever I log in and I reload, I'm logged out again. And this is really not that great. It would be nicer if we could stay authenticated so that if we reload, we already are in the authenticated state again. At least if our token is still valid. It expires after 1 hour, so we'll have to relog in thereafter anyways. But for that hour, if we reload the page, we should keep our authentication status. And that implies one important thing. Storing it on the front end, just in context, isn't enough. Because where is data stored that you store in your React context? Well, in the end, just in memory. It's stored in a variable in JavaScript in the end. It's stored in memory, and whenever you reload the page, in the end, the entire React app restarts, you could say. A page reload is like your React app restarting or starting it for the first time. And that in turn means that any memory allocated to your old React app is basically lost. So the token stored in memory is lost when you reload the page. So to have it survive page reloads, we have to store it somewhere else than in memory. And that is what we'll do now. To store the token somewhere else in memory, in app.js, when we do log in and we set the token therefore, I want to store it in a more permanent storage as well. And the browser got a couple of storage mechanisms. We can find them in the browser DevTools here actually if we go to the application area. There you find things like local storage, session storage, IndexedDB, and cookies. Now IndexedDB is a quite complex database which we don't want to use for such simple data as a token. Session storage is a bad storage because it's cleared whenever you close the browser. Local storage is great because there you can easily add and remove and manage data from JavaScript, and it survives browser restarts and page reloads. And cookies are also great, but not as easy to use from inside JavaScript. So we will use local storage to store the token. And now here is one important note. Some people are concerned about the security of local storage because you can easily write to it and read from it with JavaScript, which actually is the advantage we want to use here. It has an easy to use API. Cookies could be locked down to be not accessible from inside JavaScript, and instead we could set them with the help of some server-side headers. Now this adds extra complexity on the server side, but the most important problem with that is you have some fake security. The problem some people have with local storage is that because it's easy to access with JavaScript, if people get access to your page through a cross-site scripting attack, they can also read and write to your storage and they can steal the tokens. Now here's the error many people who have this thought process make. It's true, if your React application here is vulnerable to cross-site scripting attacks, people can steal the tokens of your users. But here's my point. If your app is vulnerable to cross-site scripting attacks, you have different problems anyways, because the attackers can send HTTP requests to the backend on your behalf, and they could attach any cookies that the users of your app have anyways. So they can still get fake access to your backend, even without stealing the token explicitly. So in general, of course, you have to build an app that does not expose cross-site scripting attack vulnerabilities, and our app here, for example, should be pretty secure. Also because React by default sanitizes anything you output and you render to the screen. So all the user-generated content we're storing in the database, when we output it on the screen with the help of React, then it's sanitized by React. So we have built-in cross-site scripting attack protection here. And unless we do something non-React-ish, we should be pretty safe therefore. So this shouldn't be a problem for us, and therefore we will use local storage to store our token. That means here, when we log in and we get the token, we can access local storage like this. This is a globally available object in JavaScript. It's a global JavaScript browser API. And we can add a new entry with set item. And here the entry I want to create is actually called user data. So not just token, but user data. And in there, I will store a JSON stringified object. Because to local storage, you can only write text or data that can be converted to text, like numbers. Objects cannot be stored, but with JSON stringify, of course, you can turn an object into text, because JSON in the end is just text, which looks like an object. So that is a way of storing an object in local storage. And here I want to include my user ID, so that UID I'm getting on a user ID key, and that token. I will store both in local storage with this command. If I now save this, and I do log in here, this succeeds. But if I now have a look at my application area, you see that there, in local storage, you have that user data entry, and that's the value for it. And that is JSON data. It looks like an object, but it's really just text. But with JSON stringify and also another method on that JSON object, we can convert it back and forth to and from JavaScript objects. So now we got our data stored here. Now that alone, of course, doesn't log us in automatically when we reload. But now we can use that stored data to log the user in when he reloads. So let's do that as a next step. So we got the token stored in local storage. Now let's use it to automatically log a user in. And for that, we basically want to run some logic whenever our React app starts. When it starts, we want to check whether the user is logged in. Now the app.js file, the app component, is basically the first component that gets rendered when the app starts. Here in index.js, I render this app component as my root component. So any logic we run in here will run when the app, well, is starting up. So if we want to run some logic here whenever this component renders for the first time, we can use useEffect in the app component. So here I will add useEffect and add a function to it that should check local storage for a token. Now the dependencies of this function will be an empty array, which means this function here will only run once when the component mounts, when it rendered for the first time. And that's, by the way, important. useEffect always runs after the render cycle. I explained this earlier in the course already. It's just important to keep in mind. React will already render this component, but of course in the unauthenticated state by default then, and thereafter run this useEffect function for the first time. This is just how React works. You could theoretically manage a state which basically is something like is checking off, and unless this effect finished, this will be true, and you render some splash screen or some fallback page until checking off is done. Here, however, I will keep it simpler and just go to use effect, and in there check our local storage. So in local storage, I can get an item and get it by that key I used to store it. So in my case, that's user data, because that is what we use to store the data. And what we extract will be text. Now we know that it's text which can be converted to a JavaScript object because it will be JSON text, or text which is using the JSON format. Thankfully in JavaScript, we got this JSON object, which does not just have a stringify method to convert objects to JSON, but also a parse method to convert JSON strings back to regular JavaScript data structures like objects. So here I then got my stored data, which I extract from local storage. And this stored data will be such an object with a user ID and a token. So now we can check if we got stored data, so if this is not undefined, so put in other words, if we did find something there. And if we do have stored data, we can check if stored data.token is a thing. If that is a thing, we know we have a token, and therefore we could log the user in. So we could execute our login function here then, and forward stored data.userid and stored data.token. These are the two pieces we need here, and we then trigger our login logic. Now actually useEffect has a dependency, and that is our login function, but thanks to use callback, this will only run once, and it will not rerun thereafter. And now here we just need to switch order and make sure we execute useEffect after these functions have been defined. So now here we ensure that login is executed with our data, with our user ID, and with the token if we got a token. So if we now save this and I reload here, you see indeed I switch to the logged in mode immediately. We see a brief flickering here because the first render cycle is in unauthenticated mode, but as I mentioned, you could avoid this by instead loading some splash screen for the very first render cycle until useEffect is done. You would just have to manage your is checking off status here inside useEffect and set it to false to indicate that you're done checking once you are done. Here, I don't really need that because it loads so fast, I don't think we have a real problem here with the user experience. So this is now using this token, but with this implementation, there are two things we're not doing. For one, when we're logging out, we're not clearing the token. That is something we can easily do. Here in logout, we just have to add local storage, remove key, and remove the user data. So that wasn't too hard. This ensures that when we do log out, we indeed stay logged out if we reload, so that we don't store the token in local storage. The more important thing we're not doing here, or the more severe thing we're not doing here, is that we're totally ignoring the fact that the token will expire. We shouldn't do that. For one, we want to log the user out automatically once the token expired. And second, when we try to auto-log in the user based on the token he might have, we of course also want to check not only if we do have a token, but if that token still is valid. So we need to include the token expiration into our logic here. So let's ensure we respect token expiration. Now, for that, in login, I know that the token will expire in 1 hour because we're building the backend, and on the backend, I configured it to expire after 1 hour. So when we log a user in, we also want to set kind of a timer after which we log the user out. And we want to derive the expected expiration date and store that in local storage as well, so that when we in the future try to auto-log in the user, we can refer to that stored expiration date and find out if the token still is valid. So let's start by creating an expiration date. My token expiration date is basically a new date which I generate, a new date object. Date, of course, is a built-in API in the browser and JavaScript. And there, I want to get my current date, which I get by calling new date again, on which I call getTime, which gives me basically the number of milliseconds that have passed since the beginning of time, if you want to call it like this, for the current date. And to that number, I add 1000 milliseconds, so 1 second, times 60 to have a minute, times 60 to have an hour. So this now generates a new date object that's based on the current date plus 1 hour. So it overall generates a date object which is now plus 1 hour. This is my token expiration date. Now this token expiration date needs to be stored as part of the user data. So here I will add an expiration key and set this equal to token expiration date. And then important here, to ISO string to ensure that no data gets lost when this date is stringified. This is a special kind of string which basically stores all the important date information and which importantly can be converted back to a date later. Now we have one problem with this logic here though. Here with this logic I always generate a new timestamp which is 1 hour in the future. Keep in mind that login also gets called from inside this useEffect logic here, which runs to automatically log our user in if we got stored data in local storage. So in the end what we need to do here is we need to verify whether the token still is valid, so if the expiration time we stored in local storage is in the future. But then when we see that it is valid and we call login, we need to pass that already stored expiration time to login as well. So that in login, we might be getting an expiration date already, which we then want to use as our token expiration date, but which we also might not get if we log in a user through the login form, in which case we want to generate a new date. So either we have an existing expiration date because we automatically log the user in due to the stored token in local storage, or we don't have that, in which case I want to generate a new one here in login. So the expiration date needs to be extracted here in useEffect as well. Now we're extracting all stored data, and part of that stored data is the expiration key, which is the originally stored expiration date. So here I can also check if we have a token, if stored data expiration is in the future. And now to check this, I will actually wrap this into new date. This will take this stored ISO string and convert it into a date object. And I want to check if new date for this saved expiration date is greater than new date like this, which is the current timestamp. Because if this date is greater than this date, it means that the expiration date is still in the future. Then the token is still valid. And if that's the case, we call login, and here as a third argument, I now forward that extracted expiration timestamp. So the originally saved expiration timestamp without any changes applied to it. This is forwarded to login, and therefore in this case we would get an expiration date and we would keep that instead of creating a new one. And when I then store this in local storage, I overwrite the existing data, but I keep the old existing expiration date. So overwriting this here is no problem. And with that, we're storing the token, we're working with the date, and we shouldn't be able to log the user in if we have an invalid date. What we're not doing is we're not setting a timer to automatically log the user out if the token then expires whilst he's active on the page. So this is the missing thing we should do next. I want to set a timer which basically ensures that we log the user out automatically if the token expired. To do this, I will add a new variable up there, logout timer. It's actually outside of my app because it's just some behind the scenes data I need to manage, not data which should re-render this component or anything like that. So it's not a state of this component, but just a general variable in this file. And now I want to use, or I want to set this timer here whenever our token changes. So we'll add a new useEffect call here. We can have more than one effect. And the dependency here is my token. If the token changes, then I want to work with my timer. Now it either changed because we logged in, no matter if we logged in through the form or through auto login, or it changed because we logged out. So here I want to check if token is valid, which is the case after a login. And in this case, I want to call set timeout here, like this, and point at the logout function if this timeout triggers. So logout, the logout function also is a dependency here. Thanks to use callback, it's never recreated, and we have no infinite loop. Now the duration here, of course, depends. Sometimes it's an hour, but after auto login, it also very likely is less than an hour. So we should make sure that we reflect this expiration time here as well. Now the expiration time changes whenever we call login in the end. Then we got a new expiration date. Hence, we can store this as state here. Token expiration date and set token expiration date. And here I call use state and set this to nothing at the beginning. In login, I then create a constant named token expiration date. Thanks to scoping, this will be a different constant than up there. But if this is confusing to you, you can choose a different name here and here then, of course. But this will not override our state or anything like that. It's just a shadowed variable in the end. I do want to call set token expiration date here though, to also set my state and set it to the derived token expiration date we got here. So I set this here, and React will batch these state updates together, so it will not update the same component 3 times. Instead, it will just batch this all into one update. And thereafter, in the next re-render cycle of this component, we'll have the correct token expiration date. So this will then be the token expiration date. So here in useEffect down there, we should also add this as a dependency now, because I will use it in this useEffect function. If I got a token, and I got a token expiration date, then I want to set my timer. Now, of course, the timeout here does not take token expiration date as a second argument though, because this is a date here and not a duration, not a number, which I need to enter here though. So we need to calculate the remaining time. So remaining time for the token to be valid is basically the token expiration time, which is a date object, minus new date, so minus the current date. Now like this won't work, but we can call get time here to again get this in milliseconds since the beginning of time, which is somewhere around 1970 in JavaScript. And here we call get time. So now we got the difference in milliseconds. And that's exactly what we need here, because set timeout wants a duration in milliseconds, so I can pass remaining time as an argument here. And with that, we set the timer to take as long as it takes for this token to expire. Now, if we have no token or no token expiration time, then I want to clear my timeout. So I want to clear any ongoing timers, because maybe we got no token anymore because we manually clicked on logout. In this case, we set the token to null, useEffect would trigger, and it would want to clear my timer, because there is no need to trigger logout again later if we logged out manually. We just might end up with multiple timers or something like this if we then log in again, which is definitely not what we want. Thankfully, set timeout returns us an ID of the timer it created, and we can store this in logout timer. So in this variable I have up there, it's just some behind the scenes data I store, so we don't need to manage this in state. And then I can use the same logout timer here to clear this timer whenever the token changes again. So when we log out, we clear the timer. When we log in, we set a new timer. So with that, we hopefully have a flow that now works. Now let's see this. If I authenticate and I log in, I am logged in, of course. Now, if I reload here, I stay logged in. Now, if I go to the application area of my DevTools here, I can edit this data a bit and go to the end and now change that time here to actually 1 hour earlier, and then let's say 50 here. If I now hit enter and I reload, I'm still logged in, but if I wait for a few seconds, this time will be reached and I should not be logged in automatically anymore, because my time is no longer in the future then. So let's wait a couple of seconds here. And indeed, now if I reload, I'm unauthenticated again. So this worked because I manually hacked this, of course, but just to prove that this auto login logic works. Now let's see if we are logged out if the timer expires. And for that, temporarily, I will reduce this login period to not 1 hour, but just to 2 seconds, so that we see if we are logged out after these 2 seconds. So if I do log in here, I'm logged in, of course, but after 2 seconds, you see the switches. However, now if I try to log in again, I immediately am unauthenticated. So something is not working correctly here. And that most likely has something to do with logout, because remember, we're having token expiration date as a state now, but in logout, I'm not clearing this. I'm clearing the token, but not expiration date. I should reset this to null here as well. Otherwise, we still have our old expiration date managed in state here, which of course will lead to an immediate logout, which I don't want. So when we log out, I also want to clear my existing token expiration date. With that, if we try this again and I do log in here, I am logged in, and after 2 seconds, I should be logged out. But if I log in again, this should be possible. Yeah, and if I reload real quick, you see, then I had my auto login going on, but of course a new timer was set, which is super short, and I am logged out. So this all seems to work, and with that, we can of course increase this again, and not wait for 2 seconds, but 1000 times 60 times 60 instead. And we therefore got properly implemented authentication with the functionality to automatically log a user in and the functionality to automatically log a user out, both after a regular form-based login or this auto login I just talked about. So this is our finished authentication flow. Now let's just do some refactoring to clean it up. We got the general authentication logic implemented. Now there's one tiny optional change I want to make. We got a lot of auth-related logic here in app.js, and you can keep it there. But I personally think a custom hook, which would manage all this user auth-related data and logic, would be quite neat. We could take all that state here, the login and the logout function, and these two use effect calls, and we could cut it all from here if we have a properly implemented hook. So we'll add my own hook here, the auth hook, and in there export a function, use auth, or however you want to name it, and then there paste in everything I just cut from app.js. Now in here, I of course need to import some things from React. I need to import use state, I need to import use callback and use effect. And I also here, of course, want to have my logout timer. So I'll cut this variable here as well and add it as a variable outside of my hook here. Now this hook should return something. It should return access to my login and logout functions as well as information about the state. So I will return token here, I will return login, and I will return logout in this object I return overall from my hook. And now in app.js, we can import use auth from shared hooks, auth hook, and then just call it like this here, use auth, and we get back an object which we can destructure, which has the token, which has the login and the logout function. Here at the bottom, I also want the user ID, so in the auth hook, we should return this as well. It is a state of this hook, so of course we can simply return user ID, this state here. I simply return this here as well, and therefore in app.js we can extract it. We can extract user ID from the object useAuth returns. And with that, our app.js file should work as before. Everything should work as before. We can now just clean up some unused imports here. But we shouldn't have any changes in the app functionality. So if I log in here, this should still work. If I reload, this works. If I manually log out, I stay logged out. If I log in again thereafter, this should also work again. Yeah, looking good. If I try to edit my place here, well, I have no places. So if I add a place here, Marienplatz, you know the place, Marienplatz 1, and pick my image and click add place. This also works. I can retrieve it here. I can add it, so clearly my token is managed correctly, otherwise the backend would complain. I can reload, and this therefore is all looking pretty neat. So with that, we added authentication, and I think with the auth hook, we also were able to outsource all the core auth logic into a separate file, and therefore keep our app.js file really lean. And this is it for authentication and authorization. As you can tell, it has multiple layers. For one, of course, it affects both the frontend and the backend. On the frontend, we want to control what we see, so that we, for example, can't edit places that don't belong to us. We want to be able to edit our own ones, of course, though. We also want to manage login and authentication there to stay logged in, but to also automatically log the user out once the token expired. And that token is the heart of authentication. On the front end, we just change what we show to the user. On the back end, on the other hand, we create this token here, a JSON web token to be precise. We can store data in it, and we then, and that's very important, we then make sure that we also validate and verify this token so that we can protect certain routes with a middleware here against unauthenticated access. We check whether we do have a token and if it's a valid token, and then we can extract data from the token and attach this to our requests. Besides this authentication logic here though, where we check whether we do have a token, we also can do authorization to ensure that, for example, only a user who created a place is able to edit it. This also is an important part of authentication and authorization, and in this module you'll learn about this part as well. With that, I just got some tiny tweaks on the backend which we can apply, but which we don't have to. The core auth logic should be clear now, and how the backend and the frontend are connected there, and what the responsibility of each side is. Now, to conclude this module, there are some tweaks which we can apply on the backend. In the places controller, for example, when we create a new place here, we're extracting the ID of the user to whom the place belongs from the request body. Now actually keep in mind that we protect this create place route here. In places routes, we can only get to this route if we are authenticated. And in the check-off middleware, I am extracting the user ID and I'm storing it on this user data object on the request. So actually it's better to not get the ID from the front-end user where invalid ID could be provided, but instead to rely on the ID we extracted from the token, which has to be attached anyways and which can't be faked. So here when I create a new place, creator will be request userdata.userid to use this automatically extracted ID which we get here in the check-off middleware. This is a better approach of getting the ID instead of getting it as part of the request body. Now, just to avoid confusion, in the places routes here, where we need a user ID to get all the places for a user, that ID should still be part of the URL, because you're able to get places of any user, to see places of any user, not just your own places. If we would get the user ID from the attached token, we would only see our own places, because that then is the only user ID we know. So here, this should be part of the URL still. Now, another tweak I want to make is that I want to ensure that whenever we return user-related data, we actually omit the password. But I think we already are doing that. So here in the places controller, we're returning a message here. Here I return the place converted to an object, but there I got no user data mixed in, it's just the place data. In create place, in the end, I return the created place, but again there we got just the user ID as part of the place, not the full user object. for find or get places by user ID, we do populate places on the user, but what I return then is just my array of places, which again just has a user ID then, and not the user data besides that. And for get place by ID, we also just return the place. Now in the user controller, when we sign up, I return user ID, email, and token. When we log in, sorry. When we sign up, I return the same though. And when we get all users, I return all my user data, but I already exclude the password here with projection. So we're already doing the right thing here, and we're never sending any confidential data over the wire here. And with that, I'm happy with the setup. Now we just need to reflect this change we made in the places controller, where we now get the user ID differently in the front end. Because now in the front end, we can adjust our code and make sure that when we add a new place here in new place.js, we no longer add the creator field to the request because we're not interested on it on the backend anyways. And with that, let's give it a try. MERN plus 2. There only is one, but still. Let's use the right address and the good old image we used before. If I now click add place, this fails. So let's see why it failed. If we go to the backend, I print null here. Yeah, of course, it fails because I'm still using creator here to find a user by ID. Here, of course, I now also have to use the ID, which is part of the request. Creator is not received anymore. So with that, however, we should be fine. Let's quickly search for creator here. This is all in different contexts, so this should be working now. If we save this and we simply resend this on the front end, now it works. Now we got 2 places here on manual. Can also delete the place, of course. And we got a working application with a little bit of a cleaner backend.